larger developments in the last 5 or 6 years. And by the way, we don't have a certified building in our practice for the last 35 years. So just to say that we just think of ourselves as a boutique practice which plans and designs projects from first principles without really worrying about the stamp of approval from a third party. So in the same way, we've been working on larger developments over the last 5 or 6 years. And we've been trying to work out what would be a practitioner's approach towards large developments, not necessarily for the rating, but simply because it's the right thing to do. And here is one of the takes on this. One easy inroad into a large development is a gated campus. Socially not a desirable thing to have gated campuses because they represent a wall of social exclusion, whether it's in Brazil, South Africa, India, which are the 3 big communities where there are lots of gated campuses. And they're almost promoted in marketing documents as a positive feature of developments. But there is one category of gated developments which is extremely good for research, and those are college campuses or educational campuses or ashrams. And I will show you some examples from each kind. And so when we came to do this project about 2 years ago, which was submitted about a year ago, which was the master plan for the IIT Jodhpur campus, we had at the back of our mind that here was an opportunity to put into practice, still at early stages, what we had been developing over the 30 years in various fields and integrate them all together. So this is the site. And you see that this site is pretty bleak and quite desert-like. It's all 200 hectares of it, 860 acres. And it's pretty much like this, silty sand, and some Jodhpur rock about 2 to 5 meters below this sand, which is a great resource, by the way, for construction. So let me show you another picture from Jodhpur. This is also Jodhpur. And Jodhpur, as some of you who might have visited there or known about the city, has an excess of water. So here is our site, 23 kilometers away on Nagaur Road. And here is Jodhpur, which represents a kind of place which has, in the last 1,000 years, to use kind of Erwin Schrödinger's kind of term, sucked negative entropy out of the environment and managed to make a living city, as it were. And how does it do that is something that I'll explain, but let me show you a few more pictures of our site. So here we are, and now it's a testament to the doubtiness of the human spirit that you see that even on a site like this, you have farming. You see that in the bottom picture. So you have the most bleak dryland farming taking place. You have acacia trees. Not all are native. Some have been brought over from Australia, been planted by various agencies and so on. And yet quite a lot of the berries are native. But that's basically the environment in which we are operating. And you see also this old water harvesting system. And these things happen if those of you come from deserts, they'll realize that the best resource you can have is an undulation in the land. So you have a slope, you have a hill, you have something in which rain falls and can be collected, and suddenly you have life. And so this particular water channel that you see runs down from the only hill, or well, the only one of 3 hills that's around, and is very gingerly caught in these sandstone channels and put towards that little lake that's no longer a lake because all the farmers have been pushed out of the site because it now belongs to a national institution, and it will continue to remain fairly barren until it is repopulated. So that's the tragedy of the way development works. But anyway, just to show you that it isn't as if there is no water. There is some amount of water, and it has been very carefully harnessed in ancient times and in medieval times. I'll intersperse my talk with some of the interpretations and background that in our studios we'd started developing about the urban pattern in a way that would have least impact. And so this is fairly well known, that we must prioritize pedestrianization by creating the appropriate density. So already in the brief of this campus, was an innocent phrase saying we must be able to get from anywhere to anywhere on a daily basis within 5 minutes. Can it be achieved for a campus of 10,000 people? No. But can 10 minutes be achieved? Yes, 10 minutes can be achieved and 5 minutes cannot be. And so we were pretty serious about this number, and we actually worked out how many meters we need to walk to be able to do this. And what we found was that if we take a few exceptions of people who live in a slightly different enclave or in a different department, who are not connected to the main institute, you can actually get a community of 10,000 people to be within 10 minutes of walking distances. You can also, of course, provide skates and bicycles, and all that will be done. But walking is actually a good primary way to measure these distances, because then every other mode of transport has an overhead in terms of the few minutes that are lost in getting that device and then in parking that device as well. The pattern of a compact city needs to be encouraged, but this doesn't need to be done by indiscriminately increasing FAR and height. We put this in because it is so easy for planners to say, oh, 1.5 FAR, let's make it 2.5. Then the next year it becomes 4, and then it becomes 5, and they say, okay, what is Manhattan's FAR? Let's find out what it is, and just start applying it. And this is a little silly because we don't have infrastructure to support that kind of thing. Good, dense, walkable cities rarely go beyond 1.2 FAR. And we can achieve that kind of dense desert settlement, which we did in Jodhpur, which I'll show you, at an FAR which is as low a density as 0.8, but it is definitely much higher than what normal campuses tend to be. Yes, the gross density is low because the site is large. But what we did was we gathered the settlement into a smaller area so that we could achieve net FAR, which was higher. A picture of Jodhpur, just as basically I've interspersed some pictures between these text slides because it relieves the tedium. And this is going to be a little bit tedious, I assure you. I'm looking at the clock a little bit, but only just so. So Jodhpur, the blue city, and this is the view from Mehrangarh Fort, the one on the right. This is the view about 10 kilometers on Nagaur Road. It happens only once. This is a temporal view, so it happens only for a few weeks every year as the migratory birds pass through. And this is what Jodhpur has done to get the blue element water into its midst. It's used every fold of the land, as it were, to create a system which is extremely complex, mired in controversy, not really fully documented, cannot be fully mapped, in which every drop of rain simply contributes to the whole water supply. There's not too much rain, but whatever there is, and in all of this area, it simply goes into a variety of ways into a whole series of water harvesting structures, some of which I'll show you after this slide. So back to the text, say the new urban areas should be in locations poor for other uses. This is an extremely important concept which we tend to forget, and therefore we get disasters like Noida on our hands, Greater Noida. We get disasters like beyond Manesar. There are issues of food versus city development is going to be a major war. In order to get a 10% benefit of foundation costs and therefore demanding flat land, I think urban developers have lost sight of the fact that as a nation, we are still living on the very edge of food security, even though that seems to be very far away, 1960s and 1970s. But we're always living on the edge of food security because the population growth and our water resources, more importantly, have never matched up with the kinds of demands that can be made on it. So for example, even today, you'll be surprised to know that 81% of everything you consume in water terms goes into making the food that you eat. That's the kind of fresh water resources that our nation is expending on simply food. It's really at the brink, a little bit more, and there could be a tipping point here. So clearly, we must use spaces which are not really very good for other uses. And then, of course, not so much in campuses, but in towns, the concept of tradable FAR and the cost of FAR starts becoming relevant, whether it's because it's close to transit or because it's not good for certain uses and so on. The pattern, however, must be adaptable. And this is the thing that I think planners have not been able to work with in the past, because cities have been seen as very static infrastructures, in which once you invest in a certain pattern of roads, sewage lines, electric lines, then they kind of remain for 100 years. But it's changing. For a start, the communication lines have become extremely flexible simply by the fact that more communication now goes on wirelessly than on wires. And I foresee that energy lines will also become fairly flexible as we go into large-scale decentralization of energy supply, or prosumers as people who produce energy at every household level or every building level and consume it as well, and so on. So there is a large amount of literature now developing in how cities can become lighter, as it were, and not lighter in weight alone, but lighter in terms of adaptability, flexibility. And when you talk about adaptability, we also need to plan static elements which are heavily investment heavy in certain public investments. And then the dynamic elements need to materialize and dematerialize whenever possible. How is it possible? A quick example from Goa. When the city of Old Goa near Ella was needed to be closed down literally because of a plague. They say an elephant died in the source of water supply, caused some disease. And so the Jesuits announced that this place was cursed and everybody had to shift 10 kilometers to the west in what is today modern Panjim. Did they lose the city, the physical infrastructure? They did not. If you walk around those ruins today, you see actually everything is taken away, not because the elements have broken down. They've actually taken it away. The method of the city building was that you have mud mortar, laterite blocks, coconut wood rafters, and Mangalore tiles, or Marseille tiles as they're called internationally. And each one of these elements, if you notice, have a resale value. They have practically 100% salvage value. So everything was salvaged. There are records to show how contractors for salvaging materials grew up. And so the whole city dematerialized. It doesn't have to be expensive. It doesn't have to be knocked down in the way we think of it as industrial housing today. But cities do dematerialize. In modern India, we do not recognize it because we've had an urban boom which has lasted so long that we haven't seen how, say, Northern American cities have become dead because they were not allowed to dematerialize. So the physical infrastructure remains, but people aren't there anymore. And the pattern must be future ready, which kind of goes with adaptable. Back to the story of Jodhpur. So this is a well, a humble well, and it's so useful to the local population that you can see what kind of a commercial activity and social and public activity goes on around something as simple as a public well. You can't even see the well anymore. There's so many things happening around it. This is the Bauli, which is a kind of simplified step well. It's not a full step well, but a directional one. And it taps a vein of water. And this is basically an equivalent of a modern tube well, except that it doesn't use that kind of energy. It uses human energy, and it uses a lot of embodied energy in the form of the labor that has gone into making of this. Then there is the proper step well. You see this, and it's wonderful architecture as well. And the jhalada. The jhalada actually taps a spring, which is different from just being a well. So there is a different level of freshness. There can be a whole fish culture that can develop in it, and so on and so forth. And occasionally it can have different temperatures of water as well. So you can have the benefit of a warm bath or something like that using water from here. So these are all taken from one single trip to Jodhpur. So they're all pretty much in the proximity of 3 to 5 kilometers from the fort. And then there's the tank. This is a proper medieval engineered structure. I must say that without using cement and steel, our forefathers seem to understand how to create such structures almost better than we do today. We have in large civil engineering all kinds of salinity issues because a lot of the construction today doesn't allow the water to breathe. There is a lack of encouragement of, say, making living cultures within this. For example, there should be fish in tanks like this for it to be able to create a sufficiently breathable kind of water and so on. And so all those elements that were possibly by chance there in medieval society have been seemingly ironed out in modern civil engineering, and that's a pity because we need to learn some of the good things that our forefathers used to do. And finally, there is Ranisar, which is a lake, part natural, part man-made. which is typically how most lakes are. It's not as if all lakes are natural. You need to probably orphan dam one part of a gorge or edge of a gully. Nainital is like that, Bhimtal is like that, Ranisar in Jodhpur is like that as well. And so while these large open bodies are not very good for evaporative loss, they form a complete cycle of how soil moisture, regeneration of subsoil channels, the creation of sufficient water in wells, and also some negative effects, like nobody in Jodhpur is now able to make basements because they really leak. Jodhpur has an excess of groundwater. And that's a kind of funny fact or a very happy fact at one point, but if you ask a Jodhpur resident in the old town, he'll be very angry about it. He'll say, let's get all the water out. There's too much water in this damn city. So that's there also as well. But anyway, that's the way life is. So this is the unintended consequence. Let me go back to the boring story. The pattern must be mixed use to the lowest viable scale. This is one of the big disservices 20th century has done to large developments, that we thought that industry is big and bad and to be separated. It was true for a while. And so it was big and bad and needed to be separated. There were sufficient noxious fumes in a glass factory for it not to be able to mix up with a residential development. But most industry today is not like that. And definitely a lot of commerce is not like that, and education and healthcare and so on. So mixed land use is almost an essential, and the faster we get down to defining how mixed land use works and what are the compatible and incompatible land uses that we should allow, the faster we will be towards the zero, because I would not just bother to go 35% on the Swagriha LD, I would want to go for zero. The pattern must allow harnessing of natural resources. Kind of is obvious, but it's not easily done, and I'll show you examples of how we try it later. And this is a corollary of that. If we harness natural resources, we must store a lot. By their nature, natural resources do not come when you want them to. So temporal storage and spatial storage are both required when you work with natural resources, whether it's water, earth, materials of any other kind, natural energy, renewable energy, and so on, or biomass. The pattern must be climate responsive and oriented. That's the urban pattern itself. It is a simple fact that many architects resist orienting whole cities in a certain direction if that's where they feel that it should be. Yet I have seen extremely well-grained cities like the city of Shanghai, for example, which has got a tremendously clean orientation where practically every building gets wonderful winter sun from the south. And they're pretty much all entered from the north. There's no shyness about it in the Chinese culture. It's partly what Feng Shui told them, and it's partly what their modern civil engineers have also concluded is good for the city. So it's very well tied up, and then they just do it consistently, which is not to say they create a boring city. Parts of Shanghai are terribly pretty and very widely varied, and parts of it, like any other modern city, are of course very boring as well. And the pattern must be structured to contain walkable neighborhoods. And this is all kind of textbook stuff now. I'd like to believe that if there is some points for what did you call it? Intra-site transport, then actually emissions should be zero. And it is very easily possible in the coming 10 or 15 years to do this for a large number of our campuses, maybe not for open cities just as yet. Back to the Jodhpur story. So we basically collected patterns of building in the desert. And one of the big patterns that we wanted to create was this crumpling of the earth. You know, we needed a change of elevation to be able to capture the water, which otherwise in this flat piece of 860 acres, so flat that the maximum elevational differences in these 860 acres is only 1 meter. So we needed that. So what we basically played with was that it's a very expensive infrastructure project anyway, and so we actually create such a hill. And that's really the center point of our master plan. It is, a lot of you will curl their toes because it sounds like a lot of intervention and a lot of very heavy intervention, and will it not all go away in erosion and so on? But that's where basically we have pegged our best bet for a long-term sustainability on water. And so we are using who we believe are the most sensitive, ecologically trained landscape and environmental design architects to be able to help us to create this kind of what you see here at this thing, which is a traditional Johar, and we are creating an artificial Johar, as it were. So we put this together, we orient it so that the forces of desertification, sand being carried by winds, cooler winds, and so on, are all in favor of the orientation of these Johars, and then we actually create it. Now, externally, if you see any living organism, which is what cities really are, buildings aren't, they're very small, they're not complex enough, but cities start approximating living organisms, even though they are man-made. And when you see living organisms, you will notice that they always have a skin. It's almost as if nature determined that life can only exist if it's bounded. It cannot exist if you prick me and just put my cytoplasm all over this hall. I will simply not remain alive anymore. Because that organism will not be able to suck that negentropy from its environment and push out entropy, which is what all living organisms do. And in a similar way, we should notice that medieval towns constantly used to create, for security in those days, walls which defined them. And therefore, whether it was Chandni Chowk in Delhi or whether it was Seville in Spain, you had strong walls which strongly defined the living organism inside those walls and therefore excluded all the non-living hinterland which is outside the walls. Not that it was disconnected with the outside, but the definition of an organism and its limits are very essential in our opinion. We don't have systemic proof of that yet, but it's a very strong hunch as we practice this. So to be able to define an edge, whether it be by cars, which is a bad way of doing it, or whether it be by the crumpled earth, or a berm, which is what I'm hinting at, or whether it be done by a fort wall, or, as in Auroville, whether it's done by a green belt, which is a forest belt, it needs to be there. And then, of course, the more they are non-gated, the more equitable, successful, and beneficial this urbanization will be. And yet, above all, this pattern, whatever we develop for our cities, really must be ours. I'm not being jingoistically Indian when I say this. I would say the same thing in every culture. Every culture needs to evolve urban patterns which they can truly call ours, which also doesn't mean that they're copied from a previous Indian urban pattern, which may have been appropriate in a certain pre-air conditioning, pre-water pumping, pre-car days. It must still respect that we are in the 21st century. There is a certain way we live. But to give an analogy, it's like you can't, for example, be doing a cut and paste copy of Jaipur, the old city today, and say, okay, I've done a great sustainable city because what was good for what was 400 years ago is what I've reproduced. It would actually just be wrong. It would be a complete parody of what one was trying to say. If there are, in my field, architecture, I found, for example, that there were extremely sensitive, content-filled architects and those who were glamorous and very form-oriented or creating a good first impression kind of thing. And it was kind of true of the modern era, 1970s, 80s in India, that they didn't really mix very easily. Let me take an analogy from a different field yet, which I think was very clear. There was a Satyajit Ray and there was a Raj Kapoor who lived in India pretty much at the same time, and they practiced their art in two different cities, but at the same time. They're contemporaneous. Satyajit Ray's stories, which is what filmmaking really is, told the story of India from a deeply authentic point of view. And Raj Kapoor's stories were also meaningful, but they had a gloss and a popular appeal. But these two stories were completely different stories. For so many years, people who went to one kind of film or the other kind of film were never being able to associate how you can ever have a fusion of these two kinds of stories. And so I find it extremely interesting to note the advent of young directors like Anurag Kashyap and so on, who actually come up with stories that are truly ours. And this is what I mean by ours. Clearly, it would make no sense to do a Sant Gyaneshwar in the 21st century in a classical religious mode and call it an Indian story, because today's Indian story is Dev D and not Sant Gyaneshwar. And so this is the Dev D that I'm talking about, identity, that the cities that we design should really be ours, but they should be ours of today and ours of tomorrow, and not really ours of the past either. Clearly, they should not be Singapore. So this is what we created, and this took a lot of doing. Then this is a quantified flowchart of the IIT Jodhpur campus. I'm not going to apologize for you not being able to read it, because it's a very large chart, but it's in our office. Those of you who want to visit me, you can see the original. And what it tries to show is the metabolism of such a settlement. I hinted at such a settlement being living, and if it has to be living, then it has a metabolism. There are two things it must do. I'm afraid I can't do the other one here yet. There are two things that living things do. They have metabolism, that means they eat and they waste, and by that they give themselves the energy and the resources to live. And they reproduce. And I'm not sure about the reproduction and how such a thing would be reproduced, because the DNA is not there yet fully. But there is at least the DNA of metabolism that we've tried to form by connecting what kinds of things will go out and in. Broadly, this diagram is as follows. The middle part has the people. The central box is the community of 10,000, which creates two kinds of outputs. It creates graduates who go all over the world. They create research, new knowledge, and what have you. So that's one kind of output. The second kind of output is that it creates skilled masons and craftsmen, which are equally important. It creates jobs for the local population, whether it's in as humble a job as supplying milk or providing services in the hostels and so on, or whether it's supplying the materials or providing a variety of other kind of skills that would be going on in such a campus. It also, of course, provides jobs for faculty, which is very small in number compared to the jobs it would provide for many others. So that's the central system, which is like, it is a little anthropomorphic because we put the people in the middle. On the upper left is the energy system. The sources are mainly the sun, directly or indirectly. On the upper right is the water system. The source is mainly rain, but it's also the Rajasthan Canal, all of 22 kilometers away. Without this, we would not be able to create such a campus and have it alive. Though we hope and expect that in about 15 to 20 years, we will be able to turn this tap off. But we know that till then we cannot. And the turning of this tap off finally depends upon our faith that we can build up the soil moisture to a requisite level so that the irrigation requirements for the food grown on this campus then becomes approximately equal to about 20 liters per capita day. So that's the kind of numerical analysis that this holding capacity thing is giving us. On the bottom right is the recycling of the water used in domestic and non-domestic uses. And on the bottom left are the building systems. So I can't give you the details too much here, and because it's such a complex little slide, but it shows you a little bit of the kind of work that our practice is now finding we increasingly do. And this almost has nothing to do, you would say, with the physical form of this campus, isn't it? And yet this diagram could not start getting made until we had at least a draft of the physical animal that we are creating. So it's like a Frankenstein's monster where we first create a body of some kind, start putting this DNA together for such a body, and then go back to that dead body and say, oh, can we breathe this life into it? And when we can't, we change a few numbers, we change a few arrows, we see what else we can do, and so on and so forth. And finally, all living systems are open systems. So finally, there's no shyness in taking something from outside and giving something outside. So this is the organism that this DNA produces. It's not an accurate statement to say it's a DNA, but this metabolism produces this organism. But importantly, it produces this organism in that particular site, or will produce such an organism in that particular site, in that climate. It could, of course, produce a different organism in a different climate. By the way, the metabolism would be different, because evaporation rates would change, the kind of productivity of soil would change, and so on and so forth. And we're all tied to that. So any campus is tied to that. And even more importantly, this so-called DNA could produce a different shape. I don't deny that. Possibly somebody else would interpret this and say, no, this doesn't have to look like a desert town like this, or doesn't have to be oriented north and south like this is. it could produce a different kind of organism. And whether it works or not is something that unfortunately takes time to judge and see. So I'm not sure how much the LD rating will be able to create good science also, which would need to depend on. Frankly, we don't know many of these issues because we haven't dealt with them, we haven't applied them in practice. But what we did feel while working on this is that there are 6 tactics to manage the physical stocks and flows. And that's important to understand. So first is that we have to use less. Using less is not a fashionable term because we have been taught that we need to have exponential growth, 5.5%, 6%, 7, 8%, whatever it is. If it's 7%, it means that we will be 1,000 times richer in our lifetimes than we were at birth as a nation. It's a very, very strong growth rate. Can it be sustained? Maybe one lifetime. But it means that our children will be 1,000,000 times richer by the time, or somebody born, our grandchildren maybe, somebody born when we are 70 years old will be 1,000,000 times richer than. Will they really be 1,000,000 times richer? What would be able to create that kind of wealth? There's nothing in the earth which would be able to provide 1,000,000 times more riches, more goods, more services in just two lifetimes. So clearly, the essentiality of this kind of work has to be with what is enough, how much is enough. And it's not fashionable, I'm repeating it again and again. What is the temperature setting that is good enough for comfortable working? What is the quantity of water that you require to bathe in? How much is enough to wash your clothes? How far can you travel by foot in 48-degree heat or shaded maybe? And so on. These are the kinds of questions which are central to our way of understanding sustainable communities and large developments. And unfortunately, so far, I'm happy to see this negative rating because so far ratings have tended to push you towards more consumption. It's true. I mean, look at the various kinds of building rating systems. You can actually kind of seemingly consume more efficiency, consume more expensive systems that can give you a better result. But here we're talking about actually questioning ourselves, do we really need a clothes dryer which is very efficient when a veranda would have done as well? And what is the more sensible approach? So that's the first factor. The second issue is, once you can use less, you can grow your own. And this is really advisedly used. Everything can be grown. And once you grow it, we are all farmers. We are not really construction people. We have to have a stewardship attitude, a farming attitude. And if you've been farmer, I have been, you know how much you depend on the weather and nature and on the vagaries of the world around us. So it makes you religious because you really, want to propitiate the gods to give you good weather, good rain, and so on and so forth. So you have to tap harvestable yields as autonomously as possible. You have to build two-way networks. Every producer and every consumer, there is really no difference in the world of the future. It's already beginning to happen in the world of energy, that you have producers as low as 800 watts feeding into the Tamil Nadu grid. This is a case I know in Auroville, for example, officially. And that we expect that once the northern and southern grid in electricity terms in India are going to be connected with that super highway which the Power Grid Corporation of India is building, we should be able to, in theory, produce wind energy in Tamil Nadu, which would be used by a northeast Indian state because it requires it at that point in time. And so 1 billion producers is what our nation has. We should not think of that as a liability, but as a great potential and a challenge for us to say, here we are. We are 1 billion producers of water. We're 1 billion producers of energy. We're 1 billion producers of materials. And 1 billion producers of waste, which is one of the greatest resources we can have, and so on and so forth. But also 1 billion consumers. But when we start doing two-way networks, whether water pipes, rainwater pipes that feed, and water supply pipes that feed the building in return. When we start making electric lines such that they can feed electrons both ways, then we start creating immense security, energy and water and resource security for the nation and for large developments. Because we are using and tapping harvestable yields, we have to store a lot. I said this earlier, natural yields do not come when you want them. Wind doesn't flow in certain seasons when you want it. Solar energy does not come at the time of day that you want it. Biomass does not get aggregated in any large quantities, but even if it did, it does not do so at will, even though it's a little better, it's more firm than solar and wind. And geothermal vents or hydroelectricity likewise cannot be easily willed to do what, for example, fossil fuels have done. In fact, fossil fuels themselves are a store of solar energy in some way. So fossil fuels are the ultimate store of what the sun's energy has put into a plant through the photosynthetic process and which has gone underground and become a source. So unless we learn to store a lot, we will really not be able to do significant large developments which have any sustainability or low impact structures. When young people today come to me to say within this field what I would suggest they work in, I think the biggest money to be made in the next generation is in storage technologies of all kinds. And I really do believe that the best career choices are for those people who will work in batteries, water storage, material storage, or cold storages, including cold chains, which are very sunrise industries, and so on and so forth. Transportless, it's a kind of obvious thing, not easy to do, but the main work that topologically planners do. How do you transport things less? So you put them in time, put them in space in ways that when you need a resource, it's there at the right time and the right place. And this is a fun jigsaw puzzle game, but it's a jigsaw puzzle that you play not only in space, but in time. So we have started developing diagrams now by which we can not only just see what's where and what's going where, but do it at different times of the day and year, so that we start getting a visual idea of how we can plan for the minimization of transport. That applies to information, it applies to water, energy, other resources. The less you transport, the better off you will be. And of course, it applies to human beings who need to get from one place to another in order to do certain work. The faster or the least emissions transportation is probably the best. And lastly, we need to intelligently exchange these resources. It's no use trying to set a low tariff for electricity and standardize it over 24 hours. We really have to have time of day metering. We have to tag electrons with where they came from. And that we're already doing indirectly. When we have the feed-in tariff mechanism, we are kind of giving a differential rate to solar energy and a differential rate to thermal power plants. But we need to do this for all kinds of things. Water, recycled water, rainwater, the molecules, the electrons, they all need to be tagged. And this is kind of possible. It's a poetic vision I'm giving you. And I'm not saying you can physically tag those molecules, but you can actually create intelligent exchanges. You can actually create logical ways of finding prices and trading without hurting the poor, because you can always set up lifeline supplies which are extremely low cost. Now, it's very often just assumed that when I say something like this, I'm basically a big bad capitalist who's out to make the life of the disadvantaged in our cities and our rural areas completely unlivable. It just doesn't work, because even as a capitalist, I would realize that those are the very people who form the basic resource of both producers and consumers that I need to respect. So in any case, this is something also which is going to be a high growth industry, the business of networking and the business of how to control, manage, negotiate in two-way networks of the various resources that flow. So I'm going to just show the last slide and discuss a bit. So when we come to, I'm so sorry, how can I play this slide? Yeah. So when we came to the overall scheme of things, this is where the trick was. We created a town which was about 1.2 kilometers across, which is actually a kind of magic dimension. You go back to various Google images of all ancient cities, they're rarely more than 2 kilometers, and they're rarely less than 0.8 kilometers. And there's no magic in it. There's not such big magic in it. The magic is only that this is your 10-minute walking distance. That's really where it comes from. And then, as modern planners, we need to ensure that we weave in the concerns of ambulances and fire escapes and firefighting. We need to weave in a variety of infrastructural systems. We need to weave in how the water gets stored, how the green infrastructure develops, where the food comes from and it goes, and where the energy comes from and how it's used at various times of the day. So I hope that at some point we'll be able to match some of the insights from our kind of practice in the LD kind of work that is now beginning to happen in a more formal vein. And with that and those thoughts, I think I have still overstretched this by 10 minutes, but thank you very much.